Okay, this may not be in the order that you see it in the playlist, but this is the last example I'm recording. We are told that the trade volume of a stock is the number of shares traded on a given day. The data in the first table in millions, so that 6.12 represents 6,120,000 shares traded, represents the volume of a certain stock traded for a random sample of 40 trading days. A second random sample of 40 days in the same year resulted in the data in the second accompanying table. All right, so is the data for the first sample to compute a point estimate for the population mean traded per day in a year. In those 40 days, we're supposed to find X bar. Your sample mean, X bar, is your point estimate for your population mean mu. And I'm going to open that in Excel. Here we go. And I expect that we will both need the sample mean and the sample standard deviation. So A1, column A1, column A, row 1 to column A, row 40, whereas our standard deviation, since it's for sample, use a .s. Tell it that it, again, is coming from the data in column A, row 1 to column A, row 40. And I can see more digits there doing this. All right, so our point estimate is 4.435 in millions. It says around the 3 decimal places, but it's not going further than that anyway. So now we need to come up with a 95% confidence interval. So 2 things. Since the sample size is 40, the number of degrees of freedom is 1 less than that, 39. On the other hand, since we're talking about a 95% confidence interval, subtract that from 100 and get 5%. Divide that by 2, get 2.5%. You want 2.5% in the right-hand tail. 2.5% is 0.025, and I'm going to go down to 39 degrees of freedom, which is right here. The 2.023 in 39 degrees of freedom, 2.023 in the column I just described. So 2.023. Okay. So we take the 4.435 there, minus, to get our lower bound, 2.023 times our standard deviation, divided by the sample size, which was 40. So when we switch it to addition, we'll have our upper bound. So I've got both pretty quickly. And let's see here. We can be 95% confident Difference between A and B. We're not talking about the number of shares. We're getting a range of values that the population mean could be between. With 95% confidence, that is not the same as probability. The author of this textbook goes into that a bit. What's the difference in all days versus per day? Click, we want D. See if I'm right. So we're going with the 95. And we're supposed to round to 3 decimal places. So the lower bound rounds down. 3 after the 8 is going to round that down. 3.908 for lower bound. And an upper bound of that 6 after the 1 is going to round that up. 4.962. Doing all right so far. Now, still talking about 95%. Sample size is also the same. So you have the same number of degrees of freedom. You're looking in the same column on the table. So that critical t-value is the same. But when we open up the data from the second and get X bar and S from the second sample, those are likely to be different. Let's find out what those are real quick. Go. Same process as before. And remembering that this is the standard deviation from a sample, which is why I have .s after the STDEV, that is short for standard deviation. So I will be replacing sorry about that. Oh, what's happening? Try that one more time. Okay, one moment. All right, whatever was just happening with the calculator there, I rebooted, so should not have a problem anymore. Place the 4.435 with 4.976. The reasons I was just talking about, we're still using the same t-value. So replace the S with what I'm typing in now. 0.139504855. Okay, lower bound. Switch it to addition to get the upper bound. Probably going to have to round to 3 places again. Let's see. Didn't need that. Okay, 4.292. Because we're still going to 3 places. Just like previously, we're talking about stocks per day with 95% confidence. So 95% confidence. That's the lower bound is 4.292. And the upper bound is 5.600. All of that in the millions. Why are they different? Well, without even reading the options, we should expect from And we've got this overall population of all of the days that stocks are being traded during a particular year. We could have selected many different samples of size 40. And we should expect that since we're using, instead of all of the information from all of the days to get our average and our standard deviation, that we're going to get different X bars in those different samples. We don't have all the scores. X bar is going to vary from sample to sample. It's not that they have different sizes. They were both 40. B starting off strong. Difference because of variation in sampling. Different means and standard deviations lead to different confidence intervals. It's not different populations. It's definitely not D. And C, we have no information suggesting that there was an error in data collection. So B looks like a good choice. And that's it.